Hi everyone, welcome back to the Geoscientist. So it's been a long time. I've been away, busy with my professional life. So I got some time. So I thought to share some more tips and tricks about TechLog. So today, what we are going to do, we are going to learn how to use Python scripts in TechLog. So there's a functionality of using different coding techniques, coding tricks in TechLog. So most of the time when I'm doing my mechanical earth modeling or geomechanics, so I rely on Python scripts. I have generated some small equations, the textbook equations, which I use, and then I can play around with them, and that helped me a lot, and it saves a lot of my time. So let's get into it. So when you go on this tree, input tree, or this is your place where you have all your wells, or the dataset tree. So right next to it is the layouts, and next to it, these blue and yellow icon is basically the Python scripts. So there are when you open a new project, you won't see any Python script over here, so you just have to create new. So I have created some Python scripts. For example, whenever I don't have a p-wave velocity data, I can estimate it using sonic log. Or if I don't have, I sometimes estimate my friction angle from primary p-wave velocity. Sometimes happens here that you don't have your density log in the shallow formations or the non-reservoir formation, and sometimes we only have two basic logs, which are gamma ray log and sonic log. So what I usually do, I estimate my synthetic density from sonic log in the non-reservoir formations, and then I merge it with the actual density log within the reservoir formations. So how to QC whether my density is accurate or not? I just display the normal density with the synthetic density, and then I play with the variables to match it with the actual density. So these are different way arounds to work on these Python scripts. So you can find a lot of these equations in textbooks, or you can just go to any AI agent online like ChatGPT or Open DeepSeek or Grok or whatever the AI agent is available. You can type it in over there what sort of equation you require for TechLog. It will type in a script for you, and you can just bring and copy and paste it in the Python window or Python scripting window and define your variables and just click and run. So I'm going to show you how you can do this. So over here, for example, I am going to estimate my velocity from sonic. I'll just click this one, and here my Python scripts open up. So first of all, you have to define the well where you are going to get an output, or where your inputs are. So for example, this is well A, for which I am going to estimate the p-wave velocity. What is the dataset name? If I may go to my dataset, so in well A, in MEM, so I have this DTCO. I'm using this DTCO, or compressional velocity, to estimate primary wave velocity, or VP. So I have defined my well, I have defined my MEM. So here you can update the date or the version. Now this window over here, here you are going to define your variables, your numbers or your curves which are you using, what sort of the name should be in the loop, labels, units, and a lot of other descriptions. So first of all, if you look at my script, it's a very simple script. I'm running a loop. So I am comparing DTCO with the missing value, where it compares with the missing value. If this statement is true, it assigns VP a missing value. So wherever I don't have a DTCO, it won't give any value for the VP. Else, so I'm using if else sort of a equation. So when my both conditions are not meeting, then it go into else. Here I am saying give me VP, and what is the equation? C1 by C1, and this is basically Gardner's equation. And no, sorry, not the Gardner's equation. So basically this is a conversion of DTCO to VP. DTCO is a microsecond per feet and VP is kilometer per second. So it's basically reciprocal. The VP is reciprocal of your sonic log. So just playing with the units to get the values in kilometer per second. So I've defined C4 as 1000, C1 is 1, 3.281 is C2, and 1 million for C3. So now here's the name DT. What would be the name in the loop? That will be DTCO. If you look at over here, that's DTCO. So whatever the name in the loop I'm using, I have to define over here. Here's VP. So VP, this should be matching with the names in the loop. Otherwise you will get a syntax error when you launch this program. Here you have to define your variables. So what is the type of these curves? So these are the variables. What is it? This is compressional slowness and this is compressional velocity. What are their units? So my compressional slowness is microsecond per feet and my velocity would be in kilometer per second, or you can do it in meter per second. It's up to you. So what is the value? So values are defined here. So value for DTCO is the DTCO log. So it would come from your well A dataset MEM. So that's the input basically. What is the mode? That's input. What will be the output? That is VP. That's my output. The format should be auto. Now what I'm going to do, I have defined all my parameters, all my variables, all my numbers, whatever I'm going to use in this equation. So I'll just go over here on the Python script, this yellow highlighted or orange highlighted on the right most on the top ribbon. So I click, so this tab will open. You just have to enter launch. You have to launch the script. The shortcut is F7. Just press F7 from your keypad. I'll just launch. So here you see the script is running and the script is ended now. Now I'll go. So it will be saved in your MEM dataset. So when I'm going over here, you see I have VP over here. So I'm opening up a new tab in the plot. Here's the log view. Now I'm going to see what it has done. So if you look over here, so it has estimated my VP for the whole well. So that's how you can use this functionality. I'll show you another example. I'll go again to the Python tab. This time I'm going to estimate my friction angle from VP. I'll just click this one. So alongside it has been open. So if you look over here, so what is my data set? A well, my well A. I have defined the well A. My data set is MEM. So what do I need? I need compressional velocity, which is VP. I need this unit 1 and my VCO or P wave velocity. Now I know the name of the curve in my data set is VP, so I'll correct it to VP. This should match with your data set name. And my output is friction angle in degrees. So I have defined all of these. My out should be the template or the format of my output should be auto. Now I'm coming over here. So this is a formula for estimating friction angle from VP. I'm just going to run this one. I'm going to Python script. I'll just hit launch. So here is my friction angle. So I'm going to drop over here. So if you see over here, I have estimated my friction angle. So you have these sort of things, small functionalities which you can use and save your time. We have certain equations in the geomechanics module for friction angle, cohesions, and stuff like that. But most of the time, you have to go and define your variables and numbers over those equations. So I find this thing a bit handy. So you can use this one for a number of things. You can do the indexing. You can do petrophysical analysis as a whole in this Python scripting. You can write a whole Python script either in Python and then copy from there and bring it into your, I would say, this Python script, or you can link it from your, here's the link, you can give it a link from here. So that's how you can use this functionality in TechLog. I hope you guys or anyone who is listening to this tutorial have gained something from it. If you like it, give it a thumbs up and share it with your fellow colleagues or students or your friends. So appreciate us by subscribing to our channel. So most of our traffic is from the non-subscribers. So I'll really will be grateful if you help us to grow our channel and help us to deliver this knowledge to the people who cannot reach. So thank you so much. See you in the next video. Bye bye.